Put x equals 2 into this fraction and it dies. 8 minus 8 on top. 2 minus 2 underneath. 0 over 0. The function is undefined there. That is not a technicality. It genuinely has no value at x equals 2. And yet the graph sails straight through that point as if nothing happened. So which is lying, the algebra or the picture? Neither is lying. They are answering different questions. The algebra answers, what is the value at 2? Nothing. There is no value. The graph answers a different question. What value is the function heading towards as x gets close to 2? Watch the point walk in from the left. X reaches 1.999, and f of x reads 11.99. Now from the right, x is 2.001, and f of x reads 12.01. Both sides are converging on 12. The function never arrives at 12 because it is not defined there, but it gets as close as you like. That is the whole idea of a limit. Not where you land, where you are headed. Here is what is actually going on, and it is not subtle once you see it. The top, x cubed minus 8, is a difference of cubes. It factors. X cubed minus 8 equals x minus 2 times x squared plus 2x plus 4. And there is the culprit. The bottom is x minus 2. The top now contains x minus 2. For every single x except 2, that factor cancels. Not approximately. Exactly. So away from x equals 2, this is not really a fraction at all. It is the parabola x squared plus 2x plus 4, wearing a disguise. Put 2 into that parabola. For plus 4 plus 4. 12. The fraction was a parabola with 1 point punched out of it. Once you know the trick, you start seeing it everywhere. X squared minus 9 over x minus 3. At x equals 3, 0 over 0 again. But x squared minus 9 is a difference of squares. X minus 3 times x plus 3. Cancel. What is left is just the straight line x plus 3. So the limit is 3 plus 3. 6. A hole in a line this time, not a parabola. Same mechanism. Now the one that does not heal, because this is what makes the difference real. 1 over x minus 2, squared. At x equals 2 the bottom is 0. Same crime scene. But look at the top. It is 1. There is no x minus 2 hiding up there to cancel. Nothing cancels. So watch what the graph does instead. As x slides towards 2, the bottom shrinks towards 0, and 1 divided by something tiny is enormous. 10, 100, 10,000. It never settles on a value. It just runs away. There is no number this function is heading towards. The limit does not exist, and redefining 1 point will not save it. So there are two kinds of broken here, and 0 over 0 does not tell you which one you have. If the thing causing the 0 on the bottom also appears on the top, it cancels. The break is then a single missing point. Mathematicians call that removable, and they mean it literally. You can define the function to equal 12 at x equals 2, and the graph becomes perfectly smooth. If nothing cancels, the break is structural. No amount of redefining 1 point will fix it. That is why 0 over 0 is called an indeterminate form. It is not an answer. It is the function telling you that you have not done enough work yet. Factor first, then look.